Good morning, class. This lecture is a continuation of what we were doing last class. Again, we were dealing with momentum. As you can see here, we're dealing with momentum, elastic collisions, and elastic collisions. This is actually going to be a very short video. We are going to, or I am going to simply go over inelastic and elastic collisions one more time. This should be the last lecture for this section. The following Monday, we're going to be having a review on everything that we've done. That way you guys are ready to take a quiz on this Tuesday. I believe that's right. Make sure. Actually, no. It's gonna be, we're gonna do this. We're gonna have a review today, and then we're going to have our quiz Monday. Okay? So, now that that's out of the way, let's get started. So, again, we have inelastic and elastic collisions. Okay? So I'm just gonna kind of like do like a T-chart so that we can compare and contrast their differences. So what is inelastic? Inelastic collision has conserves momentum, does not conserve kinetic energy or kinetic energy. Perfect inelastic has two objects stick together okay, and yeah. Now for elastic, it conserves momentum. Conserves kinetic energy. And then, well, that's pretty much it. Okay, so as you can see, they both have one thing in common: they both conserve momentum. However, an inelastic does not conserve kinetic energy, while an elastic does, and a perfectly inelastic collision has two objects sticking together. Okay? Now, actually, let's get this done first. So, the problems that you're going to be seeing for inelastic collision are going to be the type of problems where you have the objects stick together. And the equation for that is going to be this right here. So it's always about first writing the left side of the equation, then the right side, okay? And the left side is going to be in terms of the actions before the collision occurred. So let's say we have two different objects. We're going to have m1v1 plus m2v2. Okay, so this is before the collision occurs. And then the right side is going to be after it occurs. And if we're dealing with a perfectly inelastic collision, this means that the two masses are now combined. And they have a resulting mass. A resulting velocity because of that. Okay, so this is your equation for inelastic collision. Okay, now for elastic. Okay, we have m1v1 plus m2v2 is going to be equal to m1v1 prime plus m2v2 prime. Okay, Again, this just means that the two objects, they come together, they collide, and then they bounce apart, and their velocities have changed in such a way that they're not the same that they were when they first started, but their momentum is still conserved overall, meaning that the sum of the momentums from the beginning is equal to the sum of the momentums at the end. Okay? And because this is elastic, you can also have a conservation of kinetic energy for m1v1 plus 1 half m2v2 squared. It's going to be equal to 1 half m1v1 prime squared plus 1 half m2v2 prime squared. Okay? Now we won't be dealing too much with kinetic energy, but it is important for you guys to understand that because it is a very important feature of elastic collisions. Alright? Now with that being said, I'm going to move on to the last thing that I introduced but didn't really get to touch on this topic, and that is impulse. Like I said before, impulse is a change in momentum. Okay? So impulse is a change in momentum. So I, like we said before, is a change in P. Okay? So for example, let's say we have a situation where our momentum is not conserved. Something happens and the momentum we had at the beginning is not the same as the momentum we had at the end. This means something happened in such a way that impulse is now taken into consideration. Okay? So all you have to do to solve a problem that has impulse in it is you just identify your momentum at the end and you subtract the momentum from the beginning from it. Okay? And that's going to be equal to your impulse. But when I first introduced impulse, there was another equation for it. And I'm going to derive this equation again. That way it is clear that there are many ways to get the same value. Okay? That way in case on the quiz I give you this value instead of the other, it's okay because you know that there are multiple ways to go about getting the same answer. Okay? So if we remember, going from the first equation that I wrote down, I is equal to change in P, right? We know that P is equal to change in, or M change in V. Okay? And we had said before that F is equal to MA, right? So if A is equal to change in V over change in T, we can write this as change in V over change in T, okay, is equal to F. And if we multiply by change in T on both sides, we end up with M change in V is equal to F times change in T. And then we can plug this right into this, and we have impulse is equal to force times delta T. Okay? Two different ways of finding impulse. And if you see a question that requires this type of equation, usually the question will say, during a car collision, right? A collision, a car applies a force of 1,000 newtons over a period of 5 seconds. Okay, so it's applying this force over 5 seconds. What is the resulting impulse? Okay, so with that, there's a force and there's a time period, all right? That's 5 seconds that I'm going to use for my delta T. And that's how you would get your value for impulse. All right. And with that being said, that's going to be it for the lecture now. We're going to move on to the discussion on this. We're going to do, a little bit of practice problems. And then I highly, highly encourage you, any questions that you may have on anything that we did, starting from here, please, this is now the time to ask. We're going to be heading into a review because you will be having a quiz this coming Monday on all of this, okay?